Hello everyone, welcome to 1045 Engineering. We are here with yet another video in Grind 75, a Better Blind 75 coding series. So today's problem is on combination sum, which we are going to solve using backtracking. Okay, let's jump into the problem statement, understand it, and start coding. Okay, last time we have solved search in rotated array. We'll mark it checked. You can find it in the list. Let's start with combination sum. Okay, given an array of distinct integers, candidates and a target integer target, return a list of all unique combinations of candidates where the chosen number sum to target. You may return the combination in any order. Okay, the same number may be chosen from candidates an unlimited number of times. Okay, two combinations are unique if the frequency of at least one of the chosen number is different. Okay. The test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. Okay, let's understand it from the example. So we have candidates 2, 3, 6, 7, target is 7. How can we make 7 using 2, 3, 6 and 7? This question is actually similar to the coin change problem. Though the thing is that we can use any unlimited supply of each of the values, right? And now here we actually have to return all the possible combinations rather than just returning the total number of combinations. So we can use 2 plus 2 plus 3, that is 7. Similarly we can just use 7 as they showcased, right? Similarly for this example 2, 3, 5 we can do, and the target is 8, so we can do 2 plus 2 plus 2 plus 2, or we can do 2 plus 3 plus 3, or we can do 3 plus 5. Right, now some would say we could have done 3 plus 3 plus 2, but that is same as this one, right? Using 2 plus 3 plus 3 or 3 plus 3 plus 2 is same combination. Okay, so all we have to do is, what we are going to do is, we are going to go through each and every possibility one by one. We are going to make sure that we reach the target sum. We are also going to make sure that we do not include duplicates. So we will also avoid it by saying, let's say if 2 is there, next number is also 2, let's start with the next 2. Let's skip the next 2, right? Because we have already considered 2 already, and we already have unlimited supply of 2 or any candidate. Similarly we can simply avoid few combinations, like let's say for 7 we start with the traversal, we say 2, then we 2 plus 2 plus 2, it expanded 2 plus 2 4 plus 2 6 plus 2 8, right? So that surpassed the solution. So let's remove the last pointer. Let's say, let me showcase you with the example. Okay, so we have 2, 3, 6, 7, and our target is 7. So first we started with 2. Now that we are going to check for all the permutations, so we'll say 2 plus 2 plus 2 plus 2. Now this is equal to 8, right? Which is bigger than this one. So we'll remove the last 2 from the combination. We'll check for the next value from this combination, that is 3, right? 2 plus 2 plus 2, 3 is that is a solution, right? So we'll mark that as one of the combinations. Then we'll remove the last combination, that is 3 from here. We'll try with 6, not possible. Try with 7, not possible. Then we'll remove last 2 possibilities. So now 2 plus 2, and then we'll try 3. Okay, in the last one we actually said 2 plus 2. Okay, now 8 wasn't possible, so we remove 2 plus 2 plus 2, 6. We try with 3. It is not possible since it's bigger than target. We try with 6, it's not possible. Try with 7, it's not possible. So we backtrack and remove the last 2 paths. So now with 2 plus 2 we try 3, that is possible. We add it to the list. Then we backtrack, remove 3, we try with 6, not possible. Backtrack, remove 6, try with 7, not possible. Now backtrack this 2 as well. Now we'll say 2 plus 3, that is 5, plus 3, that is 8, so it's not possible. 6 is not possible, 7 is not possible. We have covered all of them, so we backtrack 2 steps. Now we remove 2 also. Now we'll say with 6 not possible, 7 not possible, so we remove these also, and then we start with 3, then we start with 6, then we start with 7. Similarly we have to start with each of the numbers. Now the thing is, if let's say this number was 10, okay, and our target is 7, so why to even test for numbers which are already bigger than our target, right? So we can skip for those situations. So where all can we skip? We can skip for duplicates, we can skip for the numbers that are bigger than targets, right? Otherwise we'll perform the complete backtrack. Clear? I hope it is clear to everyone. So let's start coding. Okay, so we have to return list of integer, right? I know it might be a little tricky to work with backtracking, but it's actually easier once you understand it. I'll make sure that I comment everything so it's easier to understand the code. Okay. Oops. Okay, so first we need a result that is going to, oops, caps lock goes on, list of integer, result is equal to new array list, right? That's done. Now list of integer will check current combinations like we were checking for this case, right? 2 plus 2 plus 3 was current combination that summed to 7, so we simply added to the main result. So we need to keep a count for current combination also. Combination is equal to new array, array list. Okay, now yeah, let's make another method for backtracking. Actually it'll be too messy to actually do it here, right? So we'll create another method, private void backtrack. Okay, no, let's call it backtrack. Okay, what all do we need to pass to this method for backtracking? In the end, in this method, in the end, I want to say return result. Okay, so it's responsibility for the backtrack method to complete this. So we want our initial candidates in candidates. How we are going to calculate for the target is, let's say I have added the target, I added the number 2, okay, in the possible combination I have added 2. Then I will pass 5 to the next backtrack. I'll remove 2 from 7 and I will pass 5. I'll add 2 again, so next time I pass 3. I add 2 again, next time I pass 1, right? Or when I pass 3, similarly next time we'll be able to find 3. So instead of passing the target every time, we pass what is the remaining value in the overall target, right? So we already have the target here. That would actually be the remaining target in the beginning, so we can actually call int remaining target, right? So that at each recursion we'll be reducing the target from the number that is already included. After 2 it was 5, after next 2 it was 3, and then 3 it was 0. So when this combination reached 0, so we know that our current combination 2 to 3 has reached 0. That means it is one of the solution we added to the result list. Okay, so int remaining target. Also we want the index, so we'll pass int start. We'll call this as the index. Then we need current combination list also, list integer current combination, right? What else is left? And of course a result list. So list of integer result, right? And that's it. So here we'll call for let me comment it, start the backtracking process. Backtracking, so what is actually backtracking? Backtracking is trying all the possible combinations to reach the final value. If any value that you have selected does not lead to the final value, remove the last part, change the last path, then change the last to last path, then change the last to last path, as we already discussed in the start of this code example, right? That is actually backtracking. So we'll call backtrack method. We want to pass candidates remaining target, that is the initial target for us. Start will pass 0 index, current combination, and result, right? Okay, now let's start coding for this one. Now here we want our first base condition. Please take time and tell me what can be the base case here. So base case is the one based upon which this method will return back, right? So since this method is getting called recursively, there will eventually reach a stage where the current combination sum has actually reached 7. That means remaining target would be 0, right? That can be the base case. So if the remaining target is 0, add the current combination to the result list, right? So we can say if remaining target equal to 0, say result dot add new array list current combination, and then simply return from this method. We don't need to process. Now in case we have not reached, this combination has not reached the final target, we'll iterate through all the candidates from the start to the end. So you can say iterate through candidates starting from start index. Okay, so for int I is equal to start, I is less than candidates dot length I plus plus. Okay, now we'll skip, remember we wanted to skip few things, so we'll skip the duplicates first. So skip duplicates to avoid duplicate combinations. So we'll say if I is greater than start, because if we have 2 in the, let's say in the given candidates we have 2, we want to consider the first 2, right? We'll skip from the next 2. So that's why we check if I is greater than the start, it's not at the same very value, right? And candidates of I is equal to candidates of I minus 1. We'll compare with the previous one. If this happens, we'll simply skip this loop, so we'll say continue. Similarly, we want another skip. When do we want another skip? If the current element at any given time is already greater, as we consider, right? If it was 10, is greater than the remaining sum, than the remaining target, then we can skip it. So let's say when we have added 2 and then 2 and we see 6. Now at this point 2 and 2, the remaining target value is 3, right? So 6 is already bigger than the remaining target, we can skip it. Similarly we can skip this one, right? So we'll say skip candidates that are greater than the remaining target. So if candidates of I is greater than remaining target, continue. Okay, now at this point, if we have reached so far, we'll add the current combination as current candidate as part of our current combination, right? So we have already added 1 2, now we add another 2, then we add another 2, right? So we can say include the current candidate in the combination. So we'll say current combination dot add we'll add candidates of I. So let's say first 2 is added to achieve this sum. Now we have added 1 2, right? And now since unlimited values of these 2 are allowed, we'll call the recursive or this backtrack method again, and we'll start from the same index. Okay, because now we can have 2 and another 2 as well. Only thing is we'll reduce the remaining target. So we'll say recursively backtrack with the updated remaining target and the same start index. So we can say backtrack, first it was candidates, remaining target minus candidates of I, because we have already included 2, then current combination and result. Now what happens is now a remaining target, when this method is called here, now candidates would be same, remaining target will become 5, right, since we have included 2. We'll check if the remaining target equal to 0. No. We'll start from start, that is 0. We'll check if it is there is a duplicate. No. We'll check if this number 2 is bigger than the remaining target. No, right? So we'll add this 2 also to our current combination. So to our current combination, 2 was already there, another 2 is added. Again we call the backtrack method. We pass the remaining target will again 5 minus 2 will remain 3. The call reaches here. We check if the remaining target is 0. No. We start from start, that is 0. We skip for duplicates, that are none. We check if candidates of I, that is 2, is greater than remaining target. No, remaining target is 3, right? So we add it to our current combination. Okay, so we add another 2 here. Now we again call for backtrack. Now the remaining target is 1. We again check the result is 0. No. We check for duplicates. No. We check candidate of I is bigger than remaining target. Yes, right? It is bigger than remaining target. 2 is already bigger than a remaining target 1. So we skip this loop. If we increment the I, 3 is also bigger than the remaining target, 6 is also bigger than remaining target, 7 is also bigger than remaining target. We have added 2, 2 and 2, and 2 plus 2 plus 2 is not the solution. 2 plus 2 plus 2 plus 2 is not the solution. If we add 3, 6 or 7 is not the solution. So we need to backtrack and remove the last added value in our current combination. We want to remove this 2, right? So how can we do that? Once we have completed this backtrack, okay, the loop comes out of this one. We'll remove the last combination. We'll say remove the last added candidate to backtrack. So we'll say current combination dot remove current combination dot size minus 1. Okay, so this way we remove the last candidate which was 2 here. So this gets removed. Okay, this loop is over. Again I value increments to 3. Okay, then 3 is checked. Is 3 bigger than our remaining targets? So, since we have come out of our last loop, so now the remaining target is updated as 3 and not 1. So we check if candidate is greater than equal to remaining target. Is greater than remaining target? No. We add it to the candidates list. So we add 3 here. Then we call the backtrack. Now the remaining target is 0. It comes here. And if the remaining target equal to 0, yes. So we add this current combination to our result list. Similarly, we remove 3 and we backtrack all the way, and in the end we'll add the 7 as well. This is it. This is the whole solution. Okay, I hope it was clear to everyone. I have mentioned what is the importance of actually removing the current combination the last added element in the last added candidate from the current combination, right? That is for the backtrack. Okay, let's run and check. Oops, something somewhere, candy dates. Okay. Remaining, REMAININGTARGET. Oh, RE, remaining target. Okay, hope there are no more typos. Oops, there are. What's wrong? Apply to given types. The solution cannot be applied to given types. Required type was int, and then int. I have passed list. So this is int, and then list. What are we expecting? Oh, we are expecting a start as well, right? So here we'll use the same start. So that would be I. Run. Okay. Okay. Let's submit. Great, with 99.88%. Okay. Now quickly, why we are passing I, the current start, every time? Because once you have resolved with all these solutions and now you have reached with combinations at 6. Okay, you are starting your combinations with 6. You do not want to include any of the combinations previously, because they were already included and the solution could not be found, or if that was found, it is already part of our result list. So with current index, the start index, we move forward with that. Okay, in next iteration we are starting from 3, next iteration we are starting from 6, next iteration we are starting from 7, and that's how we reach the 7. Okay, I hope it is clear to everyone. For anything, please let me know in the comment section. That's all from today's video, everyone. In the end, please like, share and subscribe. Thank you.